The business has always been based on trying to give the best install for our clients possible.
Good. I got Simon from Optimus Heat in, the subject matter expert in heat pumps and renewable energy. This is the reason why I'm doing the podcast, is to reduce people's utility bills. Speaking with people like you who are trying to design systems that are efficient, you can get a heat pump for 25 years.
Yeah. Government is giving some money to people that are choosing to get rid of their carbon-based heating systems.
So renewable energy.
Yeah, for renewable energy.
Understand the problems within the industry and what the consumers are having and make a positive change, because that's honestly the most important thing at the moment. Welcome back to episode 3 of the Renewable Radio. Today, fantastic. I got Simon from Optimus Heat in. He's coming in. He's a subject matter expert in heat pumps and renewable energy. And I'm really going to pick his brains into the heat pump side of his company, what he's doing, what the company's doing, and yeah, everything heat pumps. I'm so excited to have you on. Thanks for coming on, mate.
Thank you. Thanks for the invite.
It's okay, no problem. Can you give us a little introduction into everything you've been doing, please?
Sure. So Optimus was formed a couple of years ago. It was an amalgamation of my business partner Luke and myself. Luke was a gas engineer for 12, 13 years before we started Optimus. Okay. I came from a completely different industry.
Oh, really? Yeah.
So I used to be a stockbroker.
Did you? Oh, yeah. Wow, that's pretty cool, mate. I didn't know that.
No, I changed industry, came into came into plumbing. I had young children and wanted to do something different.
Yeah.
Needed a change. So a friend of mine said, why don't you look at renewables? There's a lot of maths and stuff involved in it. So I thought, give that a shot. And yeah, it's been a massive learning curve from there. I actually met Luke on BPEC training for heat pumps.
Okay.
And like they said, the rest is history. We kind of really gelled on that course.
Click like that,
yeah,
was it?
Click like that, and then
nice.
we formed the business.
Yeah.
And the business has always been based on trying to give the best install for our clients possible.
Good.
So high efficiency, doing everything right, and giving great ongoing customer support to our clients.
The way it should be.
Absolutely. They're clients for life.
Yeah, I'm a massive advocate of that. That's everything that I'm trying to do with my business and with the podcast, is giving the consumers, like, whether they are our customers, aftercare, a complete installation and looking after them properly. And your core values are definitely the same from the conversation that we've had.
Yes, we saw a gap in the market, and we saw that people weren't. There's a lot of negative noise about heat pumps.
Yeah.
People having systems that are costing loads to run, not being efficient.
Yeah.
Like costing them a lot of money on the outlay, and then not getting what they were promised.
That's
so
the
we
problem.
kind of went, our company has to be the opposite of that.
Yeah, good.
And then wrapped up in that, as we've learned, we've kind of like, although we're a small business, we're doing lots of things outside the business. Yeah. Working with different people in the industry. Honestly, it's been such a crazy 2 years. So exciting.
Yeah, cool. Yeah, it's very exciting. And like, I'm excited just from having the conversations that we've had beforehand of everything that you're doing, and I'm really looking forward to seeing your journey progress and like all the plans that you got. We're not going to go all into now because there's some NDAs flying about and stuff like that. So, but from the conversation we had, it sounds fantastic, and I'm super excited not only to see what you're doing, but hopefully use your products once they come on the market. So fantastic.
Yep.
Can you tell me a little bit about why heat pumps should be designed properly for the customers and how that will affect their utility bills moving forward?
Sure. So we like to call the heat pump the tail,
okay,
and the house the dog. And the tail should never wag the dog. So a heat pump will always work. Heat pumps have been around forever. You think about, everyone's got one in their home, it's a fridge.
Yeah.
They just work. The problem with air source heat pumps or ground source heat pumps and the negative press they've been getting is because as an industry we're so used to combustion heating.
Yeah.
And vapor compression or refrigeration heating is a completely different set of skills to combustion heating.
Yeah.
So it's kind of hard for the guys that have been doing gas, and they're having to almost relearn the trade a bit, which is not fair. But these are the changes that we're going through.
It's challenging.
You can't just put a heat pump onto a system that was using a boiler and expect it to work.
Yeah.
Might work, but
Yeah.
you can't expect it to. There needs to be an element of design and understanding of what that system's meant to be doing in order for that heat pump to work properly.
Okay. So from an installer perspective, then, going off on a tangent by here, what should the installers be doing differently when designing a heat pump for someone's property than a gas boiler?
Okay, so it's important to understand the difference between combustion heating and vapor compression heating. So with combustion heating, you turn your boiler on, the flame's there, instant heat, it works every time.
Yeah.
Vapor compression heating is a completely different animal. You're trying to take energy from the air, sometimes at very low temperatures, maybe -3, -5, and you're trying to heat water with that in your home to achieve, let's say 21 degree room temperature. Yeah. It has to work a lot harder to do that. It's not instant.
Of course.
This machine now is dependent on lots of different things. Without going too technical,
the
installer...
You'll blow my mind if I go too technical.
The installer has to have made sure the house system is capable of working with a heat pump.
Okay.
That doesn't mean they have to rip it all out. They have to change the whole thing.
Yeah.
But they have to understand the system in that home.
Yeah.
And they have to make sure that the energy coming from that heat pump is able to transfer around that system at the correct rate to give off a room temperature.
Okay. So with that, it's obviously not instant heat. Like, you turn your thermostat on, you can go out all day with a gas boiler, and you've turned your heating off, and you come on, or even if you've got a smart control, you can turn it on the way home for 20 minutes, and then you can heat from 10 degrees to say 20 within 20 to 30 minutes of turning your boiler on. With a heat pump, you can't do that. So it works more off a constant heat. You want to stay at that, say, 18 to 21 degree temperature constantly.
So the way to think about it is, and think about it from an underfloor heating perspective.
Okay.
Saying you've got a nice slab of underfloor heating, and when you turn your boiler on, saying it takes X amount of time at, say, a higher flow temperature to heat that slab.
Yeah.
If you're turning your heating on and off, that slab starts to cool down.
Yes.
It takes a lot of energy to cool it up.
Yeah.
To heat it up, sorry. Well, with a heat pump, the flow temperature is so much lower than a boiler.
Yeah.
That can take days.
Yeah.
Literally, so the way that we manage our heat pumps and the way that we design our heat pumps is to stop them or prevent them from starting. That's called cycling.
Yes.
That's what we want. We want energy just to be drip fed into the house at a very, very low temperature.
Yeah.
So it's replacing the energy leaving the home.
Yeah.
We call it energy in for energy out.
Yeah.
It's a Heat Geek saying. It's a great saying. Well done, Adam.
Yeah, if you want to come on the podcast as well, mate, you're more than welcome, Yeah, so like, that's fantastic. And the principle of how it's going to work, customers, consumers need to know the difference, because a lot of the information out there from consumers who have heat pumps, they're not necessarily designed to the best capabilities, or they're not explained to the consumers after they've had it properly. So then there's a lot of misinformation out there on the internet about heat pumps. So with that, what would you say to installers that they need to do better to hand over to the customer?
So first of all, it's understanding hydronic design, which there's some great courses out there, Heat Geek being one of them. It's a very, very involved course. I know they're producing Adam's and Adil was telling me, an installer, they're producing a simpler version of it to appeal to the wider audience.
Okay.
There is Warmer, which is Kimbo Betty's course, which is also very good. What this is doing, it's rolling right back to early days of like central heating.
Yeah.
So I remember my dad had a St Michael, Marks and Spencer's book of heating.
Okay.
And in that book, I've got it, it's in his loft to this day, it tells you all of the stuff about designing heating systems that we've forgotten.
Yeah.
The combi boiler kind of came along.
Killed the industry.
It absolutely wrecked the industry, because all of a sudden you've got a boiler that, okay, it works really well, and when energy was cheap, did its job.
Yeah.
It gave you instant hot water and it heated your home.
Yeah.
well, energy's not cheap anymore, and the game has changed. And unfortunately, heat pumps don't work well normally on the systems that combi boilers were installed on.
Yeah, so there has to be a change in the market. Yeah. I think I'm a gas engineer myself. I have a heating and a renewables company, and the skill needs to be added back into the industry instead. Like, you get so many people, you know, combi bashing, we like to call it, don't we? You know, where they just going in and you've got a 30 kilowatt boiler in there, or we'll put a brand new 30 kilowatt boiler in. You know, there's no care taken on the survey, there's no thought in the whole process, but that can't carry on when we change to heat pumps.
No.
And we need to put that information out there to engineers, to consumers, to everyone really, to upskill the industry so that we're not putting people in fuel poverty.
And I'll come back to that fuel poverty bit in a minute, because it comes off the back of everything, and it's really important. The size of a boiler, like 30 kilowatt boiler, we've just done a job which had 27 K33, like some of them 2 metre type 33 rads in there.
Big old rads.
Big house, high heat loss.
Yeah.
This was a 13.8 kilowatt heat loss on this house, and it was massive. It was old.
Yeah.
It didn't have insulation measures. It hadn't been looked after necessarily like a modern house. It was just in its old state of how it was built.
Okay.
And it was still only 13.8 kilowatt. Why are we putting in 30 kilowatt boilers on 2-bedroom terrace house?
Yeah, exactly. Yeah.
Because it's easy for it's easy in the past. We could just go, oh, you know what? I don't know what the heat loss was on that house, so I better put the 30 kilowatt in. But it's all right. Gas is only 3p.
It's the skill fade in the industry. Yeah. You know, gas engineers, they're not bothered about, is it going to be efficient for the customer? Is it going to be economical for the customer? Like with combi boilers, it's all, okay, what was in there before? What's easiest for me as a company so that we can just chuck it in, where we can't carry on that way, because I'm seeing, and I expect you are seeing, a lot of people who are having heat pumps that are not designed properly are in a lot worse position than where they should be. And the reason why you're on this podcast is to put out the correct way, because you're an award-winning heat pump company. You know, I brought you on, you're a subject matter expert within this trade, and thank you again for coming on.
No problem.
We need, especially in Wales, because I see it daily of how bad the installs are going in. We need your knowledge passed to the consumer so that they can ask the right questions on the survey and after installations to not be in a worse position by trying to go down a renewable route, because it's given us all a bad name.
Sure. First of all, just want to point out, it's not gas engineers' fault they've been put in this position. It's actually the industry and the want for something cheap that does the job, and we love that in the UK.
Instant gratification.
Instant gratification.
Yeah, that's what's wrong with the world at the minute. Instant gratification.
You go to Germany, you look at their energy systems, they have no problem in investing, say, a fifth of the property value on their energy system. Yeah. And I'm not talking wealthy people. This is everyday people, and they've always done that. Yeah. So it's a different understanding. But now we have to do that too. Yeah. And you're quite right. There's poverty, the cost of living crisis is nuts. The heat pumps that are being given out on grant quite often are on the Eco4 scheme.
Yeah.
Now, Eco4 is aimed at low-income families, people on benefits, people that really need help. Yeah. And all of a sudden, they're getting a product in their house which is installed by people that haven't designed it properly. Yeah. And all of a sudden, their energy bills, in some cases, are going up 400%.
Yeah, I know.
Because all of a sudden, they've got a heat pump that will work perfectly if the heating system is designed right. But because it isn't, all of a sudden, their bills are absolutely tragic. So you've now got someone that's at the poor end of society having kit that is now costing them an absolute fortune to run. It's just magnifying the problem.
How can we stop this from happening then as a nation? This is one of my pet peeves about everything, you know. I'm totally on board with the government helping lower income families get to fight against fuel poverty. But how do we stop these charlatans, I'll say, coming in and just doing a one-size-fits-all scope and just chucking them in, forgetting about the consumers and the customers, and then being in a worse position? Surely people like yourself should be speaking to government officials, speaking to Ofgem, speaking to all these key people to make sure that this stuff's not happening. On a design side, how can we do that?
So we absolutely are speaking to government. So we were working with, before the election, we were working with Claire Coutinho, who is the Minister for Net Zero.
Yeah.
I hope to continue that with Ed Miliband.
Yeah.
Without going into detail about our technology, we're building something that's going to help people. The training element of it is everything, and we need to be able to. I mean, HeatGeek are doing a wonderful job. They've kind of pioneered that training sector along with Kimbo Betty. Kimbo's training is brilliant as well. Very, very different training methods. So HeatGeek is an online course. The standard of HeatGeek, when I did it, was very mathematical.
Okay.
It's very intense, and I understand that they're, like I said already, they're simplifying that a bit to make it more appealing to a wider audience.
Of course.
That's such a go-to course. It's brilliant. Kimbo's is a classroom-based course. So much like Trade Mastermind, you have
travel up and
it's intense. It's like 8 till 6, and hardly any lunch break.
Death by PowerPoint.
Yeah, absolutely. But Kimbo really makes it enjoyable. It's fun. You have a good laugh doing it, but at the same time,
have you done both?
Yeah.
Have you? Yeah. Okay. Cool.
Yeah. So look, never stop learning.
I'm on board with that.
There's always new stuff to learn. There's always someone that knows something that you don't. We need to eliminate arrogance from the industry.
I agree.
It's kind of like one of the things when you get loads of heating engineers together, and they all argue over who could do the best system.
Yeah.
That needs to go.
I agree.
We need to collaborate. The only way this industry moves forward now is through collaboration, working together, sharing knowledge. Like one of the visions of Optimus from Luke and myself is that we have a social responsibility to share what we know. Like, so anyone who wants to come out of my business, anyone who wants to come do some experience with Optimus, give me a shout. You can come out and do some work experience with us. We'll train you.
I'm going to take you up on that, mate.
Yeah, of course.
Yeah, definitely.
But we absolutely mean it. We're in the throes of starting a low carbon heating apprenticeship at Brighton Met.
Wow.
We're working with Valent to try and get that off the ground.
Yeah, great.
So we're going to be fitting out the college with all Valent kit. Valent have really kindly donated all the kit there.
Valent are fantastic, I got to be honest,
Absolute market leaders. And once you get to know them, the people are like a family. They're really personable and they really do care.
Yeah.
Everything matters there. It's not just business. What they're trying to do, and I've not met the guys in Germany, but the guys in the UK, they really are trying to make a positive change.
Yeah.
Wiesmann too. Another market leader, great heat pump company.
I haven't dealt with Wiesmann, if I'm honest with you, on the boiler side or on the heat pump side. I've obviously dealt with Valent on the boiler side, and I actually reached out to them before this podcast, seeing that you was on, to ask some questions and to get a more insight into, firstly, you and your company, because you said that obviously you've won awards with Valent and stuff like that. And then I was asking them questions about their heat pumps, just so that I've got a more informative mindset while doing this. And they was fantastic as well, so thank you for that, guys.
Yeah, Mark, get him on the factory tour.
Yeah.
You'd really appreciate that.
Yeah.
It's brilliant. You get an insight into by going on the factory tour, you get an insight into how much the company cares about quality. Everything's measured. Everything's controlled. It's fascinating. Everything is controlled. So when a heat pump arrives at a customer, if there is a problem with it, there's like a complete audit trail over the whole thing.
That's cool.
And they just deal with it instantly.
Yeah.
The level of investment they've made and the level of care they have, for Luke and I, they're number one in the industry.
Yeah.
And just by speaking to the people there, the guys that run different parts of the business, they're all cut from the same cloth.
Yeah.
They're not salespeople. They're people that care. actually trying to do the right thing, which to Luke and I is super important.
That should go a long way, you know, when fitting, well, personally and for my business and everything that I'm trying to do, I only want to work with people, manufacturers or whoever I want to be involved with in business. They have to operate like that, you know, for right reasons. I don't want to go and chuck in X, Y and Z because it's 200 quid cheaper or whatever. If it's the right product for my customer and it costs my company a little bit more, I'd rather lose the money, you know, because it has to be right for the consumers, because otherwise we're just going to be in the same position that we are now, well, even worse position than we are now. If it carries on, then everyone's going to be spending thousands of pounds a year on utility bills.
There's a misconception about the Valent heat pump that it's an expensive bit of kit as well. It's not. It's like you say, it's a few £100s more than something that is not comparable.
Okay.
So what you spend and this is the message to anyone thinking about vapor compression heat pump systems. What
air source heat pumps and ground source heat pumps?
Yeah, any heat pump.
Okay.
What you spend initially, your initial outlay, whether it's high or low, over a time period, you're going to spend the same amount of money anyway. And what I mean by that is if you have a more efficient install, it costs a bit more because there's a bit more to it. We might have to change some radiators, might have to upgrade some pipework. There might be a little bit more disruption to your system. The onset from that is your energy bills all through the winter season will be cheaper. Your heat pump, because it's designed better at a lower flow temperature, will last way longer. So heat pump designed 50-degree flow temperature, the compressor is working way harder than one that's designed at say 35 or 40 degree.
Okay.
So and there's so many knock-on things from this. People ask, "Oh, heat pump's noisy." Well, no, if they're designed properly, they're not, because the noise from a heat pump isn't the fan, it's the compressor. So the higher flow temperature you design to, the noisier it is.
Yeah.
The higher flow temperature you design to, the lifespan of your heat pump shortens.
Oh, obviously, because it's going to be working harder.
Exactly.
It's like anything. The harder the appliance is working, it's going to last less time, you know. So
there are plenty of outfits out there. So Optimus Heating, we operate in the south. There are plenty of businesses, Vito Energy, Ultimate Renewables, all of these companies that are doing similar kind of installs to us that are nationwide.
Yes.
But they concentrate on making sure the system is right. Okay, the heat loss is very important.
Yes.
The initial design and understanding how your house lives and breathes, like the energy that leaves your house and the energy requirement is everything. Imagine foundations of a building. That heat loss is your foundations. If you build them strong, the building will be there forever.
Yeah.
If they're weak, it will crumble. So get the heat loss right, which size is the heat pump, and then the design comes on from that. Businesses such as Ultimate Renewables and Vito design your system. They don't just give you a heat pump and a buffer tank and say we're going to do a plant room for you. No, they look at the entire house and they go, this is the right system for you to have the heat pump installed.
So a proper heat loss calculation, look at the complete size of the system and everything that's required for that property, and then design the heat pump for that property.
Yes, so they'll look at the pipe sizing,
Yep.
They'll look at the emitter sizes. Now that could be radiators. If you're having underfloor heating, they'll design the underfloor heating around the size of the heat pump.
Yep.
All of these factors, it's like getting the heating system right is number one. The heat pump will just work. The heat pump is literally two connections, a flow and return, and three, and your electrical connections. That's it. If you get the house system right, the heat pump will never fail. Yeah. Well, very rare. Something would have to go tragically wrong with it from a manufacturing perspective, which a company like Valent would just switch out instantly. Yeah.
Well, obviously, what warranties are customers getting on heat pumps?
So it's a 7-year warranty from Valent, which you can pay to extend. And it's important to understand why it's that time period.
Okay.
Because Valent can't control what flow temperature you set that heat pump to.
So it's not necessarily the warranty of the heat pump then. So they cover you for the 7 years because that's a worst case scenario.
Yeah, if you put it in at 50 degrees, they're saying it's probably going to last 7 years.
But if
Probably.
Yeah, yeah, but they'll replace it or they'll fix it within that 7-year period. Parts and labour.
Yep.
Yeah.
Yeah.
Just standard like a boiler.
Yep.
And then like that system is obviously going to last longer than 7 years.
If you design it at a lower flow temperature, 20 years.
So you can get, as long as the heat pump is designed properly,
Yep.
and the whole calculations are correct,
Yep.
you can get a heat pump for 25 years.
Yeah. So like 3 times 35 degree flow temperature flow heat pump will generally last 3 times longer than one that's at 50 degrees.
Like nowadays, a combi boiler lasts 10 to 15 years, you know. The average cost for a combi, on a combi to combi swap, say 3 to 5 grand, depending on the size of your house, yeah. So with a heat pump, how much would a average heat pump installation cost for someone converting from combi boiler to a Vaillant heat pump?
So we have recently done semi-detached 2-bedroom house with an extension to the back of the property, and that came out just a shade under £19,000 with the pipework upgrading.
Yeah.
And the radiators upgrading.
Okay.
Then they get £7,500
off
back.
Yes.
Bus grant.
Yeah. Can you explain the bus grant a little bit?
Yeah. So it's boiler upgrade scheme. So basically, the government is giving some money to people that are choosing to get rid of their carbon-based heating systems.
So renewable energy.
Yeah, for renewable energy.
Yeah.
And that comes in lots of forms. It could be oil, gas. Yeah.
LPG, natural gas.
Exactly that. And then we've got someone that's getting rid of an Arga, an oil.
Yeah.
Like that's how they heat their home.
Yeah.
It's an old home.
It's lasted for what, 30, 35 years, you know?
Yeah, exactly. But so like there's all sorts of things it covers. The point being is you're putting the renewable energy in.
Yes.
That grant's there and it's available to you. And the problem with the bus grant is it's not being taken up quickly enough.
Yeah.
There's a number of issues with the industry. There's the paperwork. I know that people, as an installer, the MCS process is intensive.
Oh, you're telling me.
It's nuts. I mean, for solar, it's one thing.
Yeah.
For heat pumps,
different kettle of fish.
It's an absolute animal compared to solar. Like, there's so much that goes into it. It's like, you're protecting public money.
Yes, of course.
We need something.
We got to protect the public.
Yeah.
From cowboys.
Yeah,
you know?
there needs to be some regulation. There needs to be control. There needs to be a way of measuring the quality of those installs, which right now doesn't really exist.
I don't think it does. That's part of the problem, you know. Like MCS is fantastic, you know, but once you go through the rigmarole of becoming an MCS qualified company, then the quality of the work after that is not necessarily QC'd by these governing bodies the same way. You know, like I said, we've been to a couple of projects that customers have actually been left with no hot water in the whole property. Like, my company went back there, the customer reached out to us. They said, we've had a heat pump on a grant, we've had solar on a grant. It was a rural village in Carmarthenshire, and they hadn't had hot water for 9 months. They couldn't afford to put it in themselves. So the heat pump company, the grant company, come in. They said, yeah, don't worry, we'll put like whatever we've got to do on the grant, so a new heat pump, insulation, and solar. They didn't tell them how to use the system, so they had no clue at all how to use the system. Yeah. They're turning it off and only turning it on when they're cold.
Yeah, it's crazy.
Right? And they're wondering why it's never getting hot. The pipe work...
The bills would be huge as well.
Was all undersized as far as I could see. And the actual company said, we don't get paid to run your hot water to connect the hot water to your taps.
Crazy. So
like the elderly people in a worse fuel poverty position, So we went in there for 3 days and just run hot water to the sink and to two of the bathrooms completely free of charge.
I was so grateful.
Oh, honestly, like,
makes the job worth it.
Yeah,
those moments.
talking about instant gratification. That was gratification that I had, and like warm fuzzy feeling in my belly by doing something good that should have been a standard. You know, like this should be not happening, and we need to put something in place for this not to happen in the future. So I totally understand the misinformation out there on the internet about heat pumps, because I'm seeing certain things firsthand of why these people are saying heat pumps don't work. You know, we had a heat pump, my bill is 10 times more expensive than what it was when I had a gas boiler. Yes, I'm not paying for gas, but now I'm paying 400 quid a month for my electricity bill. Yep. But that's because the companies that are installing them are not doing the aftercare, not designing it properly, not explaining the system properly to them, and maybe follow up with them in a week. Oh, hi, Mrs. Jones, how's the system going? Have you been checking your bill? What's it saying? So then if they're saying, oh, well, it's cost me 4 times as much, we know as installers that's not correct. So then that company then should be like, okay, Mrs. Jones, don't worry. We'll come back out. We'll do the analytics and we'll tweak this by here. We'll tweak that by there. And then we'll make it run more efficiently and we'll check it on you in another 2 weeks.
Sure.
Do you know what I mean? And by doing that and systems being in place for the governing bodies to be able to check on installers, to be able to do that, that's only going to help us as heat pump installers or renewable energy installers to stop the bad press about heat pumps and about solar, you know?
So let me explain a little bit about heat pumps and the importance of efficiency and what consumers need to look out for when they're shopping for a heat pump. So when a heat pump starts, it's at its most efficient setting. Yeah. It's like starting a car. You want to get that car onto the motorway in 6th gear, and that's when you get your good miles per gallon. Yeah. So the heat pump starts up, it does what we call modulate. So it modulates down. It's akin to turning a flame down. Yeah. Modulating boilers, that's what they do. They adjust the flame. So we want that heat pump to modulate down, and then what we don't want it to do is turn off, because if it turns off, it has to repeat that process over and over, and that's called cycling. So what we're aiming to do, and our systems, this is how we design them. We design them for under 1 start an hour. Okay. Now we can do that.
What does that mean, under 1 start an hour?
So what that means is the heat pump switches on, modulates down, it doesn't switch off.
So it just stays at a constant, like
trickling in energy. Yeah. And the way you achieve that is by understanding how energy leaves the building. So, quick example: you've got a 2 up, 2 down house, 10 kilowatt heat pump. Each room is 2.5 kilowatts, so 10 kilowatt load. Yeah. If that house is all open loop and it's all working, excellent. The heat pump's going to switch on. It's going to turn down because the load of the house is 10 kilowatt. Yeah. And you've got a 10 kilowatt heat pump feeding it. In the old days, we used to turn upstairs off. Yeah. We don't use bedrooms in the day. But all of a sudden, if you did it with a heat pump, you've taken half the system volume away. Yeah. So that 10 kilowatt heat pump is essentially a 20 kilowatt heat pump. That's what it does. It's only got to heat 2 rooms, so it switches on. Yeah. Oh, I've reached temperature, turn off. Switch on, turn off. So it cycles. Okay. Any boiler product, so any on-off control, I'm not going to name names, but you think about any of these smart heating controls. Yes. Is just the light switch. Yeah. They are literally telling the heat pump to turn energy on, energy off. Yeah. They don't work with heat pumps.
So constant heat is better than turning on and off.
Correct. So the first question to your installer is, what controls are you using? Okay. If they give you any control other than the heat pump's own controls, red flag number 1.
So if it's a Valent if it's a Valent heat pump, then they should be using Valent controls. Yeah. Exactly. If it's a Ideal heat pump, they should be using Ideal controls. Exactly. If it's a Wiesmann heat pump, they should be using Wiesmann controls. Exactly. Yeah. Okay.
Weather compensated controls. That means the heat pump's checking what the temperature is outside. Yeah. So at -3, it will give you X amount of power. Yeah. but at 7 degrees, it will give you a whole lot less power.
Yeah.
To reach the same room temperature.
Because it's about the end temperature. It's not about heating, say, to 65 degrees straight away. Because the outside temperature, say the outside temperature is 5 degrees and you want to heat 35 degrees, like you said.
Yep.
Then you've only got to heat 30 degrees. But if the outside temperature is 0 degrees, then you've got to heat 35 degrees.
Exactly. It's giving you more power output to achieve that delta T.
Yeah.
So the next thing to look out for with a heat pump is flow temperature.
Okay.
So if a company says to you, we're going to design your system at 50 degree flow temperature, you need to ask them why.
What if the company is not telling you what flow temperature they're going to design it for? If they're just saying, we will put a 10 kilowatt heat pump in. No explanation of how it's working or what flow temperature or anything like that. Is that a red flag?
No, absolutely. And if you're getting a bus grant, they absolutely have to tell you that.
Okay.
Yeah, so you have to tell the client the design.
Yeah.
It comes on an MCS kind of documentation, which is pretty standard. It's fairly easy to see what the design flow temperature is on there.
Okay.
50 degrees, 55 degrees, mega alarm bells. 50 degrees, which is what most of the larger companies that are putting in heat pumps are designing to.
Yeah, are these the companies chucking them in for 500 quid?
Yeah, exactly.
You know?
It means they have to do less work to the house to get your install in. The knock-on effects of that is your heat pump lifespan will be much shorter.
Yeah.
And your energy bills, because it's working a lot harder, so every degree is 3% efficiency on a heat pump.
Wow.
So if you think about one that's running at 35 degrees as opposed to one that's running at 45 degrees, 30% efficiency difference just by 10 degree flow temperature.
If it's 50 degrees, then
You're going up and up and up. And what that does, it makes the compressor work harder, which makes your energy consumption higher, which makes your bills higher.
Yeah.
So what we want to be aiming for, we start to design at 35 degrees. It's not always possible to do that. Sometimes that means really big radiators, and you have to work with the client around the system they want, as well as designing a super duper heating system.
Yeah, it has to be right for, it's not a one size fits all with renewable energy, Yes, we want to make it as efficient as possible, but it depends on the customer's budget as well,
Of course. And as a business, Optimus, we've kind of got there's a couple of projects aside from this that are unique projects, but we have an upper limit of 45 degree flow temperature design.
Okay.
And we rarely design at that level.
Do you make the customer aware of that then? If it's going to be going, say, above 45 degrees, would you say potentially this is not really optimal for you?
So there's other ways of, and again, it comes back to budget. There's other ways of conquering that. So we've got a project at the moment that I'm quoting for, which we're using a product called Thermoskirt.
Okay.
So it's a 3-pipe system.
Yep.
And it's a skirting board that's basically a heated skirting board.
Yeah.
On its own, at 35 degree flow temperature, you'd have to have a super insulated house for that to work well. But that doesn't mean you can't add a few radiators with that. But those radiators, all of a sudden, if you hadn't got the Thermoskirt there, because it's energy in for energy out, that's giving you some wattage.
Yeah.
Those radiators can become smaller.
Yeah.
Like boiler radiators.
Yeah.
And all of a sudden, you've got a normal looking system.
Yeah.
Again, it all comes down to budget. And I think that the bus grant needs to change. We've got this big pool of money sitting there, and people are able to claim £7,500. That doesn't really...
How does that work then? So... for consumers where they're thinking about having heat pumps, they know that there's potential, and that grant can be for anyone it doesn't matter about income.
Nope.
If they have a heat pump, they will have the bus grant, yeah?
Yeah, it's up to a certain size system. If you've got like a Buckingham Palace got one, the system would be too big.
Yeah.
So it's on a normal domestic property, but that covers most properties in the UK, right?
So for consumers, if you are going to have a heat pump, then the bus grant will be available to you, and it will be £7,500, yeah?
Yeah.
This is a question that I get asked quite a lot. So if you're having a heat pump and you're going to have the £7,500, would the customer still have to pay for the installation?
Absolutely.
At the for the complete installation, then apply for the bus grant, and then they get repaid that into their account.
So the rules, as it's set out, state that the business owner must carry the bus grant.
Okay.
I'm not sure that every business on the street does it that way.
Yeah.
And a lot of people will charge the client and refund it, because imagine, so you've got your boiler business going on at the moment. Imagine if you had to carry £7,500 for every one of your installs next month.
Yeah, cash flow would be a nightmare. Yeah.
So it's in some cases it's not feasible for businesses to do that.
Okay.
So there's a mixture of how people run these things, and that's their business, up to them.
Yeah, of course.
What needs to happen, and the more pertinent question is, £7,500 enough? Well, it's enough for a bad heat pump install, with maybe the client putting £1,000 or £2,000 to do a good install, where you're looking at the pipe, you're looking at radiators, you're looking at doing the right thing to get that 35 degree, 40 degree install.
Designing it properly so that the consumer has reasonable utility bills and not in fuel poverty. So you're just saying, to do it correctly,
Yep.
what needs to happen?
Well, like I said to you, that 2-bedroom house that we did was £18,000. So now you make that bus grant £15,000.
Okay.
All of a sudden, that's a boiler swap, because the client's got to make up what they would normally do for the boiler.
So at the moment so if it was 18 grand, it would be £10,500 that the consumer would have to, or the customer would have to pay, and the 7.5 would be offset against the full 18,000.
Correct.
Okay, so it's not quite enough to be able to do it correctly then.
But the money's sitting there not being used, which is the crazy thing. So the uptake is slow. The government's messaging, or the previous government's messaging, is that we want to get to 600,000 heat pumps by 2030.
Which is
How
a
do we
great
do that?
target, yeah.
We make heat pumps more accessible for the average people that would have them installed, and we do that by increasing the grant and putting in the right systems. There's another thing about having the right systems that's super important. Yes, by putting in an efficient system, your energy bills are cheaper.
Yes.
But cost of energy should not be our primary concern with heat pumps. The electrification of energy across our homes is happening.
Yes.
And we do not have a grid that can support it. So imagine you get a heat pump in your home today. It's all great. It's all working fine. Now imagine, not going to happen, but overnight, your entire city got a heat pump installed.
The grid's not big enough to be able to cope with it.
At, say, 300% efficiency or 250% efficiency, which a lot of these Eco4 type bad installs are. If you change that to a 450, 500, 550% efficiency, which is entirely possible with the right designed heating system, all of a sudden the load on the grid is significantly lower. And people are going to kind of go, oh yeah, you would say that because you want more money, but actually it's about doing it right. We haven't done heating systems right in the UK for years.
It's the big picture.
And now we need to change
It's funded a little bit better to design and install the systems better, so that the government hasn't got the massive upgrade of the grid.
Correct.
You know, so it's just a different way of looking at it. What you're saying is, so the funding 7,500 at the moment for, say, I don't know, how many do you say, 600,000 properties?
600,000 heat pumps by 2030. They want.
Yeah.
Look, that budget they've got, that pool of money.
So that's 7,500 times 600.
Potentially, unless the money runs out.
Yeah. So,
and even if they get close, but even if they did 300,000, right?
Yeah.
If they did 300,000 right, rather than 600 wrong.
No, yeah.
What's the better?
But so playing a bit of devil's advocate by you, okay? So with the 7,500 and the 600,000 properties, whatever that sum would be, say they designed bad, so they only working at 100 or 200% efficiency.
Yep.
So then the government would still have to upgrade the grid, because we're going to have to go EV chargers, like every property is potentially going to have heat pumps and whatnot with that. But if you was to say each property get 15,000 and they work at 500% efficiency, then the government would have to pay less on the upgrade of the grid, so then potentially they'd save money a different way.
Correct.
Yeah,
and
so
there's another element here, right? So the spark gap, electricity roughly 3 to 4 times the price of gas, dependent on where
it's about 4 times the cost of gas at the moment, but that's going to go the other way.
Sure, your heat pump has to be 400% efficient to get the same even price to run as a gas boiler.
Yeah.
So straight away, Eco 4, bad installs. Like people, these are all, Eco 4 isn't bad, but this is where a lot of the horror stories come from.
Yeah.
If you've got a 150 or a 200% heat pump install, that's someone that's a low-income family that's now paying double the cost of their heating.
It's wrong.
Just by having a technology flung in. So it's almost like they've had the free technology, but to try and help them, but now their bills are doubled.
Yeah, because there's no caretaking in it. Like it's bodies. I'm not tarnishing everyone with the same brush by here, because I've also seen some good installations by these Eco4 schemes, and I would like to be able to offer this package and be part of the Eco4 scheme for my company, but do it the correct way. But I'm finding it very difficult to be able to do that at the moment, okay? And I will do that on another podcast. But we need to do things properly. Like, some of these companies are just operating for profit only, not caring about the consumer and what their end bill is going to be. All they're thinking is, if I put a heat pump in, then I'm going to get X, Y, and Z from the government, and it doesn't matter what the end user's bills are, which is not right.
And this comes down to governance, and this is only changed by the way that we regulate the industry. And if you go on several Facebook forums, there's some really good, heatpump.co.uk, Paul Spence's Facebook, some great content on there. And Paul is not a fan of MCS, to say at the least.
Oh, okay.
And but he's right.
It can't just be all MCS though. It got to be,
highest. So you get insurance backed.
Yeah, we are HICE. We are accredited with HICE, Trustmark, MCS, and obviously gas.
So this stuff's money for old rope.
Yeah.
Like for someone like myself, who's putting in these efficient installs, I invite MCS to come and see my install.
Exactly.
I want them to. What actually needs to happen is we need to harness technology in a way where every install can be audited.
Yeah.
And that's coming.
Yeah.
That's
is it?
Absolutely. Yeah, I'm building it.
Oh, yeah. Yeah. This is where
Yeah, it absolutely is coming. And we need to prove that systems are being
done correctly.
Yeah. For 2 reasons. Yes, we need to protect public money, and 2, we need to protect the public.
Got to protect the consumer.
Absolutely.
Because, like, for people to be thinking, shall I buy food this month, or shall I turn my heating on, is a travesty, and like something has to be changed. This is the reason why I'm doing the podcast, is to reduce people's utility bills, and speaking with people like you who are trying to design systems that are efficient, that are lowering people's utility bills. And like, it's vitally important that things like this go out there, that hopefully someone with influence can see and understand the problems within the industry and what the consumers are having, and make a positive change, because that's honestly the most important thing at the moment.
Sure.